This is the pre-lab video for the acid-base properties lab. Remember, when you're doing this, there are pre-lab questions on the paper, so in addition to doing this ed puzzle, you want to make sure you do this paper too, this pre-lab, because we will check this when you come in. The procedure. There are 4 different procedures that individually are not very difficult. You just want to make sure you follow the directions. One of the things you want to watch out for this first procedure, it says to use 1 molar HCl. We're also going to use 3 molar HCl in other procedures, so make sure you double check the label that it's 1 molar HCl. We're also going to use a couple indicators, and the whole point of this first procedure is to see how an acid and a base respond to the different indicators. What you're going to do is pour out about 15 milliliters of the acid into a small beaker, and then you're going to test it with the different indicators. Now, what the directions tell you to do is to take, and in this case this is blue litmus paper, hold it with tweezers and dip it into the liquid. Now, another way you could do this is use a glass stirring rod. And what I would actually do is dip the glass stirring rod into the liquid and then touch it to the litmus paper. There's not many options of what you can see with the red and blue litmus paper. The blue litmus paper is either going to turn red or stay blue. And the red litmus paper is either going to turn blue or stay red. And you want to make note of what happens with that. Now, you're also going to use what's called pH paper, and this stuff starts off with this tan color. You're going to do the same thing, test it with the liquid, and it's going to turn a color. And then what you want to do is compare it to a standard that we have, and there's a bunch hanging up around the room, and basically you're going to get an idea of what the pH is depending on what color it turns. You're going to do the same thing with half molar sodium hydroxide. Now, you're also going to check liquid indicators. We have phenolphthalein, bromothymol blue, and methyl orange. And what you're going to do for this is you're going to take a little bit of the liquid out of the beaker and you're going to pour it onto the watch glass. And if you want to, you can use an eyedropper for this. And then you take a drop of an indicator, one at a time, and you drop it on the liquid and you see how it responds. And then when you check one indicator, you pour that down the drain, wipe off the watch glass, and you do it again, the acid with the next indicator. Just make sure you clean it off in between. Then you're going to repeat with the sodium hydroxide. So you're really checking all these indicators with both liquids and writing down what you see. Is it going to change color? Does it stay colorless? What helps for something like this is to put something white underneath the watch glass so you can kind of see the color a little easier. When it's on top of the black counter, it's a little hard. When you're done with this section, all the pieces of paper that you have, I would just put them on the paper towel, and you can dispose of those, just throw them in the trash all at the same time. Make sure the papers do not end up in the sink. I don't want the sinks getting clogged because you were careless and the papers end up there. All right, that is the first procedure. The second procedure is testing how acids and bases react with metals. Now, for this one, you're using 3 molar HCl. Make sure you don't have the 1 molar. Go for the 3 molar. You want to pour about 20 milliliters into a beaker. And the reason why you're doing this is now you are using this to pour out of, so other people would be able to get the main bottle, the stock bottle. It says to get 2 pieces of the metals. Now, for the magnesium, that's easy because it's this ribbon that's cut up. Right? For the other metals, what we actually have is ground up. It's in a powder. So for a lot of this, what we're going to do is use a well plate. This is one where I'm doing things a little different than the directions. The well plate will allow you to go through this a little quicker instead of everyone waiting for the bottles to be available. For magnesium, the first time you test magnesium, you're going to test it with hydrochloric acid. And you've done this experiment before. What you're going to do is put a piece of magnesium into the test tube, and you're going to fill it up with a certain amount of hydrochloric acid. Now, that is going to start bubbling. You're generating a gas. What you want to do, and you want to get the timing right for this, you want to have a Bunsen burner lit before you add the liquid and the solid. You want to have a Bunsen burner lit, and you want to get a wood splint caught on fire. Because once that liquid and that metal start reacting, you're going to generate a gas. And you want to collect that gas with the test tube let it collect for maybe 10 seconds or 15 seconds, and then you just do a quick test and it'll give you an idea of what gas is being produced. You only do that wood splint test with magnesium and acid. After you're done that one, the rest of the solids you check on the well plate. You don't need to do the flaming splint test. For the sodium hydroxide, you're going to test all those on the well plate. You can do them all at the same time, and you should be able to record your observations. When you're done, make sure you don't put any of these metals down the drain. They all get thrown out into the metal trash can. Just rinse this out with some DI water from our squirt bottles. All right, for part C, you are reacting an acid, and in this case we're using 3 molar HCl again, and you're going to react it with calcium carbonate. So for us, we have these marble chips. And you're going to need a large test tube, a small test tube, lime water, and this stopper assembly. So what you're going to do is pour the lime water into the small test tube, about halfway or so, maybe a little more than halfway. And then you're going to put some calcium carbonate, some chips, into the large test tube, and you're going to pour some of the acid onto the chips. You want to put the stopper assembly on it because it's going to start forming a gas, and you're going to make sure this tube is submerged in the lime water. And we have done this experiment before when we were predicting products. Remember, if lime water turns cloudy, you're producing carbon dioxide. And again, when you're done, make sure no solids go down the drain. All right, the fourth, this is a very quick version of a neutralization reaction. What you're going to use is make sure you have 1 molar HCl. Do not use 3 molar. 1 molar HCl, half molar sodium hydroxide. You will need phenolphthalein. An eyedropper would help probably. You want a watch glass, and again, you want to put it over something white. And then you want some pH paper. And again, the scales are around the room telling you which color goes with which pH. You're going to add 10 drops of the hydrochloric acid. Use the eyedropper on the watch glass. Make sure you add the phenolphthalein. That is the indicator. If you don't have the phenolphthalein, you won't see anything happen in this lab. So 1 drop of the phenolphthalein, and you want to test it with the pH paper and write down what you see. Then what you do is you add sodium hydroxide to the watch glass, and you stir it very gently. You don't want it spilling out. You shouldn't have much liquid on here, so just a very gentle stir, and you're going to start seeing some color changes. And what you want to do is count how many drops of sodium hydroxide you have to add until that color change is permanent. And write down those numbers in the data table and check the pH again with the pH paper. And at the end, again, make sure no solids go down the drain, no papers in the sink. You should be able to clean everything up at that point and answer the rest of the questions in the lab based off of your observations.